All right, today we're going to work on solving trig equations by factoring. And on example number 1 here, we actually don't need to factor. And in fact, when I look at this secant of x, first thing I notice, it doesn't have a square, so obviously factoring is out. So this would be one I'm just going to solve. So step 1, I need to get rid of this plus 2, so I have minus 2 from both sides. Okay, and so far I've got square root of secant of x equals negative 2. Step 2, whoops, I forgot the square root of 2 here. I'm going to divide by the square root of 2 for both sides. Divide by square root of 2. That goes away. And then I'm going to get basically secant of x. Secant of x equals negative 2 over the square root of 2. Now, at this point, you might think that you're going to rationalize the denominator, multiply by a fancy 1 here to get the square root of the bottom, but you don't want to do that, okay? And the reason being is I don't like that I have a secant of x over here, okay? Secant of x is not one of the items like sine, cosine, or tangent on the unit circle. So instead, I have to refer to what it's related to. And secant is directly related to cosine of x. And you'll remember that cosine of x, if I were to make a fraction here, is adjacent over hypotenuse. And secant is the inverse of that. So by flipping these fractions here, this would be hypotenuse over adjacent. So basically, all I have to do is flip the fractions. So if I want to find cosine, this would be a negative square root of 2 over 2. And now I have no need to rationalize the denominator. Okay. Now, once I have sine, cosine, or tangent all by themselves, no squared, okay, now it's unit circle time. So I am looking for negative square root of 2 in the first position. And I notice it's going to be right here, and then it's going to be over here. So I have 2 answers in this scenario. So I'm going to scroll up a little bit here. So the angles that would create negative square root of 2 over 2, okay, would be right here at 3 pi over 4 and right here at 5 pi over 4. So my answers are 3 pi, get back to a pen, 3 pi over 4 and 5 pi over 4. Now this would be my solution set if I took 1 lap around the unit circle, okay? And if I notice that my instructions say what are the values for x between 0 and right brushing up to 2 pi, this would be my answer. Now, if I notice that it says all solutions, now technically if I look at the unit circle, okay, I could go 135 degrees or 3 pi over 4 to get me here, or I could do another full 360 degrees on top of that to get to the same spot, or another 360 degrees to get to the same spot. So technically, there's an infinite number of solutions, okay, to get to the same line. Okay, I'm in the same boat if I'm down here at 225 degrees, okay? I could do 225 to get there, or I could do another 360 to get in the same spot, or I could add another 360. I could just keep going and going and going. So if it does say all solutions here, okay, the way I would write that out, the notation here is a little bit funky. I would say, okay, x can equal 3 pi over 4, or x can equal 5 pi over 4, or I can just keep going around. If I'm not limited to 1 lap around the circle, I could say 2 pi, and then I'm going to do n here, plus 2 pi, because again, 2 pi is 360 degrees. Now, what does n stand for? Okay, I'm going to say that n here is, n is an element of this funky z here, which means rational, means integers, okay? So the notation would be, I'll write it down here, n is an element of integers. And basically what that means, if I were to cover up n here, it means I could say, okay, it's 3 pi over 4, which is technically 135 degrees, or it could add 360 to it, okay? Or if I slapped in a 2 for my integer, that would be 2 full laps around. Add another 720 to that answer. Or if I did 3, that's 3 laps, and it just keeps going up and up and up for on and on forever. Okay, next one. Example 2. All right, this one is going to be something that I'm going to factor here. So, and it's kind of a dead giveaway that I factor when I see a sine squared and a sine. I'm not going to be able to use a square root. Okay, that would mess things up. So I'm going to go ahead and get everything to one side. So I'll say 2 sine squared of x minus sine of x equals minus 1 equals 0. Now I'm going to go ahead and set up my binomials. Okay, the only items that multiply together to give me 2 sine squared have to go in these first positions. And my only option, since 2 is prime, is 2 sine of x and 1 sine of x. Okay, whatever goes in the last terms have to multiply to negative 1. And I know my signs have to be different. And so it's either plus minus or minus plus. I might have to flip-flop those later. And then luckily, 1 is also prime. The only whole numbers that multiply to 1 are 1 and 1. So 1 and 1. Now I am going to do a mental check here. I don't waste my time foiling right there. I know that 2 sine times 1 sine makes 2 sine squared. I don't waste my time multiplying positive 1 by negative 1, or the last part of FOIL, because I know that's going to make negative 1. We came up with that stuff. I do quickly check my outers and inners. Okay, my inners are 1 sine of x. My outers are negative 2 sine of x. And combining those together does make this middle term of negative 1 sine of x. So you do have to check that your outers and inners actually factor correctly. Okay, once I get to this point, I'm going to turn this into 2 equations. Okay, when does 2 sine of x plus 1 equals 0? And when does sine of x minus 1 equals 0? Because again, my goal is what x values would turn everything to 0. And for example, if I put a 0 in this set of parentheses, it'd be 0 times, well, I don't really even care what's over here, because 0 times whatever's in this set of parentheses equals 0. Likewise, okay, if I had an x value that would turn everything on the right to 0, and I had a 0 here, it'd be 0 times, well, whatever this is, but who cares, because 0 times whatever is going to be 0. So basically, I want to know what's going to turn everything in the left to 0 and what's going to turn everything into the right 0. Now, the nice thing is these are quick, either one-step or two-step equations. Like this problem, easy, one-step equation, add 1 to both sides. So I get sine of x equals positive 1. Okay, on the left, I got to do a two-step equation. To get rid of this, I would subtract. To get rid of this, I would divide. And on the left, I get sine of x equals negative 1/2. Okay, once I get to a point where it's just the trig name by itself, okay, no squares, I'm on to the unit circle. Now you'll have to remember on the unit circle, the first coordinate's cosine, the second coordinate sine, the outer coordinate is tangent. And I am looking for positive 1 and negative 1/2 in the second coordinate. And I notice positive 1, boom, right there. I notice negative 1/2. I've got 1 right here, and I've got 1 right here. So I have 3 separate answers. Now, technically, these can be in any order, but I'm going to put them in order as if I were starting from 0 and going in the correct direction of the unit circle, okay, in a counterclockwise rotation. So I'm going to start off in radians, pi over 2, which is technically 90 degrees, 7 pi over 6, and 11 pi over 6. Now, if I'm only making 1 lap around the unit circle, like it says right here, this would be my final answer. Okay? If I am continually going around the unit circle, for example, there's other ways to get to this. I could do 90 degrees or pi over 2, or I could do one full circle and get to the same spot, or I could do two full circles and get to the same spot like I did last time. Okay, the notation for that, again, I've got three answers this time. X equals pi over 2 plus 2 pi n. X equals, let's extend that up, 7 pi over 6 plus 2 pi n. And you remember 2 pi is 360 degrees, or one lap around this circle. 11 pi over 6 plus 2 square root of n. And again, n is an element of integers. Okay, problem number 3. Now, this one's a little weird. It looks like it's set up to factor, but I have an issue here. I've got sine squared and cosine. I have to have the same trig ratio. It will not factor properly if I have different names. So I'm going to change this one. And looking at my table over here, I notice sine squared is equivalent to 1 minus cosine squared. Okay, so if I were to write this out, I would say instead of sine squared, I'm doing 1 minus cosine squared of x. So it was sine squared, now it's this. And then I'm going to go minus 3 equals 0. I'm going to go ahead and distribute, get rid of my parentheses. Okay, so I get 2 minus 2 cosine squared of x plus 3 cosine of x minus 3. I can combine some like terms here. I can put this negative 3 and this positive 2 together. At this point, I've got negative 2 cosine squared of x plus 3 cosine of x. This will give me minus 1. Now, I do have an issue here. Okay? I don't like this negative here. I don't like having a negative in front. But I can think about moving everything to the other side. For example, if I wanted to move this over, I would add 2 cosine squared of x to both sides, right? In fact, I'm going to move everything over to the right side of the equation. So basically, I'm trying to get to a point where the 0 is over here on the left. And technically, it would just change all these signs if I moved everything to the right side. Then it'll be something that's a little bit cleaner that I can factor. 2 cosine squared of x. Now I have negative 3 cosine of x. I have positive 1. Okay, now it looks like something that is factorable. Okay, I've got cosine squared. I've got a single cosine. I've got a whole number. All right, so go ahead and set up your parentheses here. We'll decide what goes in the two binomials. It's a lot like the last problem. Okay, whatever goes in these first terms has to make 2 cosine squared. Since 2 is prime, my only options are 2 cosine of x and 1 cosine of x. For my last terms, my signs have to be the same, and then this middle term tells me they have to both be negatives. So it'll be negative, negative, and since 1's prime, those are my only options. I check my outers and inners. That's negative cosine of x. This is negative 2 cosine of x. So it factors correctly. All right, at this point, I'm going to go ahead and make 2 equations. When does this left side, cosine of x minus 1 equal 0? And when does cosine of x minus 1 equal 0? Okay, the one on the left is a 2-step equation. Okay, I would have to add 1 to both sides and divide by 2. And when I do that, I get cosine of x equals 1/2. And this is a 1-step equation. I would have to add 1 to both sides. When does cosine of x equal positive 1? Okay, now I'm onto the unit circle. The instructions up here above didn't ask for all solutions. They only asked from 0 to right brushing up to 2 pi. So I'm going to do 1 lap around the circle. And you'll have to remember that cosine is the first coordinate. So I'm looking for a positive 1 and a positive 1/2. I see positive 1 right there. I see positive 1/2 right there. And I see positive 1/2 right there. So my solution set for angles in radians would be pi over 3 Oh, I guess I better start with 0. 0 pi over 3 and 5 pi over 3. Final answer. Done. Okay, last problem. Looks like this. Okay, I'm not going to move anything. I'm not going to change anything. I like the fact that I have sine squared, sine, whole number. So I'm going to go ahead and set up my binomials here. Since 3 sine squared is prime, my only options are 3 sine of x and 1 sine of x. I look up here and I notice that my signs, okay, and I mean like my pluses or minuses, have to be different. So it's either plus, minus, or no, excuse me, they have to be the same, and they both have to be negatives. So it's got to be minus and minus. And then it's either 1 and 8 or 2 and 4. And I believe 2 and 4 work. But again, I'm going to check. That's negative 2 sine of x. Oops, sine of x. And this is negative 12 sine of x. And those do combine to make negative 14. So I'm going to get rid of those. Okay, at this point, I'm going to go ahead and make my two equations. When does 3 sine of x minus 2 equals 0? And when does sine of x minus 4 equals 0? This is a one-step equation. So I would add 4 to each side to get this. And then over here, this is a two-step equation. I'm going to add 2, divide by 3. I get sine of x equals 2/3. Now, one of these is impossible. Okay? The one on the right here is never going to work. And the reason being is I know sine is opposite over hype. And if I were to draw a quick picture of this, that's telling me that if I had a reference angle here, I don't know what it is, that the numbers that would plug in would be 4 over 1. And you are never going to have a right triangle where this opposite side is larger than the hypotenuse. Okay? So if you do not have a fraction that's less than 1, okay, it doesn't matter if this were positive or negative. I could have triangles that go up or down. It's not going to work. Okay? So impossible. Now, I got a weird situation here. Okay? This right here is not on the unit circle. Okay? And that doesn't mean there's an answer. It just means it's not going to be one of these pretty numbers like pi over 6 or pi over 4 or pi over 3. Okay? It's not created by a special right triangle. It's created by a right triangle where the opposite here is 2 and the hypotenuse is 3. Or vice versa, I could have a different right triangle that's oriented a little bit different. Here's the algebra behind this. I'm going to do this in degrees and then I'll switch to radians. So sine of x equals 2/3. And you'll have to remember the opposite of sine of x is sine inverse. And if I do it on the left side, I have to do it on the right side. Sine inverse. These cancel each other out. Boom, boom. Okay, on my calculator, I think I already typed it in. So here's my answer. The inverse of 2/3 is 41.8. I'll go ahead and pull this off here. And so, roughly looking at my unit circle here, I know this is 45. So that means just a little bit below it. Okay, if I were to make a right triangle that looks like this, that means this would be 2 and this would be 3 if I had a radius that was 3 instead of 1. So this is one of my angles. So x is approximately equal to 41.8 degrees. Now you'll notice there is another right triangle. Okay, so I'm going to say this is 41.8 degrees. There is another right triangle over here to the left. Okay, that's about in this vicinity. That would also have a positive 2 and a positive 3. Now I wouldn't go down here because this is negative 2 over positive 3. And I'm not looking for negative 2/3. Okay, so again, right here, boom, boom, 2/3. And again, I know if this is 41.8, okay, but I'm not looking for that angle. I'm looking for this angle that goes from here to here. And you'll notice if half a circle is 180, I just took 180 and I subtracted that. So my other answer is x is approximately equal to 138.2 degrees, and we'll round. Now, what if they want this in radians? Well, if they want it in radians, I got to do a quick conversion. I'm going to turn this into a fraction and this into a fraction. I'm going to go ahead and multiply by my conversion, which is 180 degrees over pi. And I'll do the same down here, 180 degrees over pi. And usually in radians, we don't include pi in the measurement. So I'm basically just going to turn this into a decimal and this into a decimal. And you're going to get approximately, let's see, what do we get this one? About 0.23 pi radians and 0.77 pi radians. Now, just looking at the pictures I did up above, okay, I know that this point right here is 1/4 of pi, which is 0.25. And so hopefully that makes sense that 0.23 pi is a little bit lower than that. And I also noticed that this point right here is 3/4 of pi, which is 0.75. And that point's a little bit bigger here, 0.77. So hopefully that makes sense. And again, I probably would take either one of these answers. I would take it in degrees since it's not a nice, pretty number that's on the unit circle, or I would take it in radians.